So the next part of our sort of toolkit of how to develop projects, we've got Dr. Tim Johnson, who works for Jacobs, and he is going to talk about the various technologies, the conversion technologies that could be utilised depending on your feedstocks and your particular environment. So he's a chartered engineer, and he's been working in scientific, technical, engineering and management posts. He's advised on coal, oil, nuclear, gas and renewable energy power stations. We don't have any nuclear power stations in Australia, and Tim's come from the UK, so that's why he's advised on those. But he's also really interested in biomass projects and has actually advised on those as well in the UK, because there are many more in Europe than there are in Australia. He's looked at gasification, combustion technologies, and was independent engineer on the pioneering landfill gas to LNG project at Albury. He is of interest to us because he managed the bioenergy roadmap process that we began last year. So he was responsible for a spatial data map that we have on our website that shows you quantities of feedstocks, and it also matches those feedstocks with demand for heat and electricity. So welcome, Tim.
Good morning, or no, yes, still good morning, guys. And thank you very much, Catherine, for that very warm introduction. As Catherine says, we did some work last year for her looking at a bioenergy roadmap, or starting off a bioenergy roadmap for South Australia. And as part of that, we had three major goals, really. One is to identify where the sources of bioenergy might be. Secondly, to identify where there were non-electrical demands for energy, because we'd identified, and Chris made quite clear in his presentation, that projects work rather better if you can use most of the energy in the bioenergy and not just sell the 1/3 of the energy or so as electricity. And the third one was what sort of different technologies there were and how those could be adapted, and how we could identify a number of model type projects as examples of what could be done. So my plan in this little short talk is just to talk a little bit about the current landscape for bioenergy, and here I'll bring in a little bit of international experience, because I've been involved in bioenergy in Europe for a number of years before I came to Australia about 4 years ago. We'll have a look at some of the logistical issues briefly, look at the technology options, some typical case studies, and we'll leave it there and see what questions come. So if we look at the current landscape, particularly in Europe, also in China, there's enormous investment in bioenergy. There's, I think it was mentioned just how many anaerobic digesters were going up in Germany at the moment. A lot of this is driven by government policy, and a lot of that government policy is leading to advanced technologies as well as existing technologies. But we see a large number of different models which are being adopted in other countries. We see in Australia, mostly, it's capture of gas from decomposing wastes and combustion of waste rock materials. We don't, for example, see a lot of gasification or pyrolysis type projects in Australia at the moment. And just to give a flavour, one of the things we did as part of the roadmap development was just see what bioenergy projects were running in South Australia at the moment. I'm sure this list isn't exhaustive. It doesn't mention some of the ones which we heard about earlier this morning from Pete's Technologies, but it gives an example of some of the things which are happening. So the roadmap work we did and the mapping work we did, and Mary will talk a little bit about it later, just after this talk, I think, did identify at quite a granular level just how much bioenergy there was available. And we identified it in two different ways. Existing sources of bioenergy, things which are around at the moment, and it's a matter of utilising them, and identifying whether converting the bioenergy sources into bioenergy or doing something else with them is viable. But the other thing we identified, and it was particularly relevant, I think, in other parts of the state rather than the Limestone Coast, but in other parts of the state, there did appear to be a lot of opportunity for actually developing bioenergy sources as purpose-built crops. This was particularly relevant where we had non-productive cleared land. particularly relevant where there was sufficient rainfall but not excessive rainfall, which meant other things were easily grown. And so we've identified in some other areas of South Australia where potentially you could have energy crops and create power stations burning energy crops. Not particularly relevant to this part of the world, but it is particularly relevant elsewhere in South Australia. And one of the major issues we identified, and I think is well known, and it's been mentioned before, are the logistical challenges. Yes, you can get around logistical challenges, as was described earlier, by making wood pellets rather than have wood wastes. But generally speaking, unless you can move materials around by boat, then you've got to actually have quite short transport distances. We believe that 40 to 50 kilometres is quite common as a sensible distance. You can go up to 100 kilometres. I did notice in the forestry presentation earlier this morning they were talking up to 120 kilometres. It becomes more difficult. Yes, you get a lot more material, it becomes more expensive to get it in. And that's a sophisticated wagon for moving straw around, which we photographed when we were in China recently. For some biomasses, there are some quite sophisticated vehicles. So what sort of technologies are we talking about? There are lots. And we've identified in our report, and it's on the website of Catherine's website, RenewablesSA, typical project definitions for about 10 different types of feedstock. There are some similarities between them. There is quite a lot of difference also in scale. We have tended to look towards the larger scale opportunities, mainly because larger scale opportunities tend to have better economics than smaller scale ones. It's not a given. There are specific niche areas where you can have small projects, but generally speaking, there are a lot of fixed costs in project development, and if you can spread those fixed costs over a larger project, your economics benefit a little bit. So what we'll do is I'll take a few of these examples and just talk through a little bit about some of the technology choices you've got if you want to look at, say, council green waste or municipal solid waste. So if we look at green waste or sorted municipal wastes, you've got really two major options. You can combust the waste, or you can use anaerobic digestion and get a biogas from it. Combustion offers some significant advantages, and if I bring this up here so I can remember what I'm going to say, so I can look at you rather than look at the screen, bear with me 1 second. The big issue really is how much you've got left. If you've got woody materials and so on, you can actually divert more via combustion. And the picture I've got there is the New Haven in the UK municipal solid waste to energy plant. It's one of a series of plants which were built in the south of England. This is the fourth one in a series in just one regional area of UK, which is similar in size to South Australia. There they have 4 plants, each of around 30 megawatts. This is the fourth one. And so they're producing 120 megawatts of electricity from diverting waste from landfill. And most of that material which is being diverted is organic, and so probably about 70% of that would be considered renewable energy. And so you can produce a lot of energy. You have a lower capex per tonne if you burn it than if you use anaerobic digestion, and I'll put a few numbers up in a moment on that. But of course you can't actually do very much if it's wet. If the material you're working on has high moisture content, then a lot of the energy in combustion gets taken up by just converting that moisture into vapour, and so your efficiency in your energy production goes down dramatically. So your anaerobic digestion really works well if you've got high moisture content feedstocks. And also, as was mentioned earlier, if you're using anaerobic digestion, the material which promptly comes out of the bottom of the digester, depending on what particular one you're using, can potentially be a product in its own right. Whilst the material that comes out of combustion processes tends to be fairly contaminated, tends to mean it has to go to a registered landfill, and you still have got, therefore, landfill costs. There is work going on in Adelaide at the moment looking at how that can be treated so it isn't actually an expensive landfill issue. But that's still under development. So if we look at a little bit more about the anaerobic digestion side, you really can put lots of different things into anaerobic digesters. Animal manure is a classic chicken waste or waste from most livestock. Food waste, garden wastes, anything with moisture contents in excess of around 55-60%. And you can find, depending on the types of feedstocks, that you can have very short digestion residence times, but it can, for some other materials, it can take a long time, which of course ties up equipment and isn't so good. And similarly, you can have batch or continuous processes. Quite often batch processes allow you to put a load of stuff in and collect some gas off and then dump it out again, but continuous processes give you a more steady flow of gas, and that has its advantages of itself. You've got to do a certain amount of gas cleanup, but you don't need to do very much for quite a few of the uses of the gas. Typically you're going to get 55 to 75% methane, which is pretty good and means that you can burn the gas directly, though that is not a very efficient way of using the energy in the gas. Far better probably to use a spark ignition gas engine. You can import one from China, as we heard this morning, or there are lots of other suppliers. It's a very well established technology. And there, if you use a spark ignition engine, you've still got a certain amount of waste heat available to you, which is probably a reasonable quality. It can be done something with it. Progressively, in some parts of the world, fuel cells are becoming more popular. Fuel cells are expensive, but the conversion efficiency is far, far higher. So if you really want to make electricity as your main purpose, a fuel cell in the future, as prices come down, as Chris says, prices are coming down in some of these technologies. This is the classic area where fuel cells, where we would expect price to come down. Or you can upgrade it to biomethane, and I'll talk a bit about that later on, because that's the sort of a second level of upgrading. So a couple of the advantages on options of these. The spark ignition engines, you get power at fairly high efficiency, although fuel cells are more efficient. Presently they're too expensive probably. It's very well established, lots of them around. There is a lot, for example, SA Water is doing a lot of this, of using from sewage wastes. And they are bringing in other organic materials to supplement the sewage waste so they can get more energy out by bringing in more kit into their AD converters. And it's very readily scalable. We saw this morning how quite small digesters, were they 3 or 4 meters in diameter? Yep. And almost you can get ones of that size, or you can get things like this. This is one in Western Australia where presently we're engineering 1.2 megawatt spark ignition engines to go on the backside of it. So they can come quite big. But alternatively, you could just have a heat-only boiler if you really don't want to spend much money, and if there's no grid connection, because even if you put it is expensive to run a standalone power system if you want to have reliable power, so it's probable that you'll still want some form of power connection. I don't know whether you managed to get away with that one, but for many users, they still need a power connection for the time, if nothing else, to start up the kit. But low capital cost, obviously, if you have a heat-only boiler. And at the bigger scale, then you can use gas turbines, because gas turbines have one great advantage over the spark ignition engines, and that is they can produce, from the exhaust gases, they can produce steam, and they can produce steam at far higher process conditions. So if you want high pressure steam, high temperature steam for a particular use, then you put a gas turbine engine on rather than the spark ignition engine. And so it really depends on what you're actually looking at and how you integrate your AD process into a bigger process. So this one, I believe the intention there is just to produce electricity. I don't believe there's any intention on this particular one and to use the material out of the AD but digest it for other uses. There isn't a particular heat demand. Forest and sawmill residues, we heard a lot about that this morning, and understand the differences between pellets and wood chips. Of course, a major opportunity in the bioenergy sphere is to actually use wood chips and to make pellets. And that I've been involved in a number of projects in Europe where that has been the ambition. You burn the wood chips or you gasify the wood chips, and I've been involved in both of those sort of processes. Typically you burn the wood chips, you'll put the combustion gases go through a boiler, you make some high pressure steam, you use some of that steam for the production of the pellets, and you use some of the steam through a steam turbine to make electricity. And then you have a great advantage that depending on the price of electricity, you can bias your process. If the electricity price is particularly low at any particular time, then you can actually concentrate and put more steam and make more pellets, and vice versa. So you can actually operate to take advantage of the variations in the electricity price. If there's a peak in the electricity price, you stop your pellet production and you make more electricity. And certainly in some markets, in Western Australia is a good one, and in part in the NEM, there are very high prices available at certain periods of time. And so if you have a plant which makes electricity and can make more electricity by diverting some steam, you can take advantage of very high prices. And those sort of projects really have got two particular commercialized technologies. At the larger scale, typically you'll have a steam cycle and you'll have a steam turbine, and you'll use some of the steam, as I say, if you can. There are standalone projects in Europe, quite a few, typically at 20, 40, 60 megawatt size. A couple of years ago in Europe, the 300 megawatt size was very popular, and I think at one stage I was involved in 7 different projects in the UK at 300 megawatt burning imported wood chip. None of them got off the ground. They were all dependent on government policy, and government policy is very important on which projects happen and which don't. But then shortly after that, the UK made a major commitment, for example, for producing coal combustion. And several of the power stations of very large size, typical to the larger power stations in Victoria, converted to 100% biomass. It meant that they had to downgrade, so a 1,000 megawatt power station burning coal will become something like a 700 megawatt power station burning biomass. But that made a lot of money for a few people for a few years. And the biggest power station in the UK, which is called Drax, made a policy about 5 years ago to convert itself from a coal-fired power station. It was around 3,000 megawatts, which I think is bigger than any power station in Australia at the moment, and it decided to go to 100% biomass. And it's buying its biomass predominantly from those rather large projects which we saw in the southeastern corner of the United States. Those very big new projects are predominantly providing biomass to places like Drax and places in Germany. Now, at the smaller scale, you tend not to get the ability to have very high steam conditions, and so what you can do is you can burn the process rather more cheaply at a lower temperature, and you can, instead of using steam as a working fluid to produce electricity, you can use an organic fluid, and that's normally called an ORC, or an organic Rankine cycle, which means you can use lower quality heat and you can still convert that into electricity. This has become popular also for geothermal power stations. If you don't get high quality geothermal steam or geothermal hot water, you can use an organic cycle. And similarly, you can use organic Rankine cycles to convert low-grade heat out of other engines. There was a company, for example, in Perth, which is just trying to commercialize this process at the moment. It works particularly well if the oil price is high. And I think that company's really struggled when the oil price collapsed last year. And clearly, if you can operate with combined heat and power, and when I use heat here, I use heat in a generic sense, if you can use some process energy as well as power, makes things a lot better. There are lots of them around. Here's a picture of a typical 10 megawatt one. Gives you an indication of the sort of scale. You've got the store for the fuel on the right-hand side. The conveyor takes it into a little boiler house. The blue building, which is double height building, is the turbine hall. And then you've got various ancillary bits of kit around it. It's well proven, well established. Finally, and I said to Catherine that if I had time, and she stood up, so I think I've just about got time, I would talk a little bit about something which is happening a lot, and I believe will happen a lot more in future, is that if you're going to have anaerobic digestion and it catches on in a big way, then you may not wish to just use the gas yourself. You may wish to export the gas in some way. And the normal way to export biogas is to upgrade it and to make biomethane. And this was the project I was involved with in Albury in the UK some years ago. It happened to be a very large waste dump which had a lot of biogas coming out of it, at around 50-55% methane. It didn't have an electrical connection, and so there wasn't an opportunity to put a spark engine on the site, and so they actually converted it into a vehicle fuel. They converted it up to natural gas standards, and that's a fairly straightforward thing to do. And then they actually liquefied it and made a liquid Bio-LNG. And that, in the UK at the time, had a very high premium price, and so there's a good business opportunity there. But there are two real options here. There are probably now about 50 grid injection points in the UK where people have got anaerobic digestion or digestion from sewage or whatever, and they're actually upgrading the gas up to a suitable condition where they can inject it into the high-pressure gas grid. There are lots of other people who are using it as a transport fuel. You can use compressed natural gas or LNG. There are arguments around the benefits and comparative benefits of both, but it's quite often it can work as an integrated process. It can work, for example, and the mention was made of the company who are using a lot of biodiesel. An alternative to that process, and other companies in the UK have done it, is to create biogas, compress the natural biogas and use that in the transport fleet. And it means you can, and some councils also are doing that because they can claim they're a carbon-free council. So there are lots of different opportunities. I've only mentioned a few here. There are a lot more opportunities and a lot more case studies, a lot more data in the report, which is on Catherine's website. Thank you. Yep, any questions?
Would you like some questions? Do we have any questions?
Go for it.
Jim, good day from my gasifiers. We have a small scale, medium scale gasification technology developed over the last several years. You didn't mention gasification as being a suitable technology. I know it's a report. You do mention it, you mentioned very, very high cost. I'm just wondering what happens when you get a technology that has much more reasonable cost. Is that something that you see as beneficial in the region?
Definitely beneficial. The complication I've got, and it's possibly that I've been burnt, or gasified, or whatever the expression is. There have been a number of projects I've been involved in where fairly small companies have developed gasifiers, and they've made them work at the prototype scale, and they've gone on to their first commercial one, and something's gone wrong. And it's one of these technology issues that, at the moment, I would like to see evidence of several commercial ones in operation before I'd recommend someone do it themselves.
One of the non-transparent barriers that we come against is having developed it at the commercial scale. We have consultants recommend against us without ever coming and seeing us, without ever seeing the technology, and we've had a lot of projects fall over for that reason.
I've had the opposite experience, you see. I've been the consultant who said, yes, okay, give it a try, and then it's gone wrong, and we one gasification project, which was a very sensible project. It was taking wood chip, it was going to gasify it, put it through spark ignition engines, and it was going to take the waste heat and make pellets. Perfectly good project. Unfortunately, all it produced was an enormous amount of tar, which clogged up the gasifier. And yet I've been involved in another one in the UK which had some 300 kilowatt electrical gasifiers, and they worked fine. So I would say is, unless you're a technology developer, then I would say if you're be a technology user, and you need to persuade someone to take the initial risk. Good. Yeah. But the other thing is they're more expensive. Genbacker will probably, Genbacker would normally offer something to go on the back of a gasifier.
Sorry?
Genbacker normally would offer something.
They've got a pricing structure designed to capture all the value out of it. Now we've got two jobs which use Genbacker engines at a lower price than Genbacker, so
let's take that conversation off the line for lunchtime maybe. Have we got another question for Tim before we go to the next?
Yeah.
How small a plant is there available if you just want to do it yourself? That's the micro wood chips or whatever.
Well, if you're going for a heat-only plant, as small as you like.
Right.
And if you're just producing a hot water plant, there are masses of commercially available biomass. But it's certainly sold in Europe in a great volume, so I would imagine they're sold here in Australia as well. If you wanted to go to the next stage and make electricity as well, then there are some solid-state fuel cells which work at domestic scale. There are some, you would otherwise have to go into quite a complicated cycle. So I don't think it will be expensive if it's small scale. But heat only works well.
One final question for Tim? No? Thank you very much.
Okay, no worries.